Hello everyone, welcome to Homeschooling channel. This is the last part of Circle chapter. In this part we are going to cover a few previous year questions that have been asked previously. Uh, in this there will be a lot of tough questions also. So let's start this video. Now this one is an easy one. This was asked previously in previous year. In the figure above, PQ and RQ are tangent to the circle at point P and R. Okay, these two are tangents at point P and R. If the radius of a circle is 12, so if we take this as a center, so in the question it is given, it is the radius is 12 and this is also 12. We have to find what is the length of minor arc PR. So as we know, radius is always perpendicular to the tangent. So this is 90 degree, this is 90 degree, 180 degree, this is 60 degree, and we know uh, sum of all angles in a quadrilateral is 360 degree. So this angle would be 180. These two angles are 180, and this would be 180 minus 60, 120 degree. So we know theta, what theta is. So now we can find the length of arc. Length of arc is equal to theta by 360. So theta here is 120 by 360 into 2 pi r. So r is 12. So this will go 3 times. This will go 4 times. So your answer is 8 pi. So this is your answer. Moving to the next question. So this is a little tricky question here. In the figure above, PA and PB are tangents to circle with point O, and the radius AO. This radius AO is 6. If this is 6, then this one is also 6. If the measure of angle APB is 60 degrees, so if this angle is 60 degree, which of the following is closest to the area of shaded region? So we have to find what is the area of this shaded region. So now how we are going to approach it? We know that these two angles would be 90 degree, and if this is 60 degree, so this is going to be 120 degree. Now what we are going to do here is we are going to draw a line. Let draw a line OP. So if we draw this, so as we know that uh, tangent to a particular point, the both the tangents to a particular point are equal. So if AP and BP is equal, so their opposite angle would be also equal. So this angle will be equal to this angle. So total angle is 120. So this one is going to be 60, and this one is also going to be 60. Similarly, these two OA and OB are radius, both the sides are equal, so their opposite angle would be also equal. So these two angles would be 30, total is 60, so these two angles are equal, so both are 30 degree. Now from here we are going to find the area of the sector. Area of sector OAB. So we have to find the area of this whole sector. So for that would be the theta by 360. So theta, this whole angle is 120 by 360, and area is pi r square. So r is going to be 36. 6 square is 36. So this is going to be go 10 times, and so answer area of this sector is 12 pi. Now, now if we have divided this quadrilateral into two triangles, so we know this, and we know it's a right triangle. So if we are able to find this, then then we would be able to find the area of whole triangle. So let's we have to find what is AP. AP in trigonometry and right triangle chapter we have read uh, tan theta would be height AP by AO. So the angle is 60 degree. So tan 60 degree AP by AO is 6. So tan 60 uh, is how much? Tan 60 is root 3. Tan 60 is root 3 and AP by 6. So AP is 6 root 3. So if this is 6 root 3, so this also, because these are tangent to the same point, so this will be also similar, 6 root 3. Now area, now we have to find the area of this triangle. So area of triangle OAP, as we can see this angle is 90 degree, so it's a right triangle. So for right triangle the formula is half into base into height. So base OA is 6 and this height AP is 6 root 3. So 3 times, so it is going to be 18 root 3. So similarly, if this so if we want to find the area of whole quadrilateral, then we have to multiply this triangle into 2. So this triangle plus this triangle, so if we uh, area of quadrilateral OAPB, OAPB is equal to 2 into 8, twice of the triangle, area of the triangle OAP, 18 roots. So this is going to be 36 root 3. So let me find what is going to be its value on calculator. So it is 62.28. So we have to find the area of shaded region. So area of shaded region is equal to area of quadrilateral, that is 62.28 minus area of sector, that is 12 pi. So if we calculate what is 12 pi here, 30 minus 37.68, so it is going to be 24.6 something. So which of the following is closest to the area of shaded? So the area is 24.6, so it is closest to 25. So 25 is going to be your answer. Now moving to the next question. On a first look, this question seems a little bit difficult, but trust me, this is not difficult at all. So in the question, point O is the center, okay, of the circle, and we know these two angles. We have to find what is the value f of value of x. So we know OP, this is going to be r, and OR is also be r, that is radius. And if we join from uh, and if we draw a line from here, OQ, so this will be also equal to the radius, so we can take this one is also as r. So as we know that if this is the length OQ, OQ is equal to OP, which is equal to radius. So if if length of both the sides are equal, then their corresponding angles would be also equal. So if this is 23, then this is also going to be 23. Similarly, this is also radius, this is also equal to the radius. So their corresponding angles, their opposite angles would be equal. So this is also going to be 29 degree. If this one is 29, so this is also going to be 29 in this triangle. So now we know x is equal to 23 plus 29 degree. So answer would be 9 plus 3, 2, 1 carry 5. So this is going to be your answer. Now moving to the next question. This one is this one was asked few years back. Similar type of question was asked few years back. So this is a very important question. So now let's see what they are saying in the question. The figure above, each side of a right each side of right triangle ABC with angle B, this is 90 degree, okay, and are tangents to the circle. Okay, all sides are tangent to the circle. Length of AB is 10, okay, and length of BC is 24. What is the radius? So we have to find this is, if this is our center, we have to find the radius r. So first we have to find this AC. AC is, if we use Pythagoras theorem, so AC is equal to AC square, AC is equal to 24 square plus 10 square. So 24 square is going to be how much? Let me calculate. 576 plus 10 square 100. So this is equal to 676. So the 676 is under is going to be 26. 26 square is 676. So now we know the value. Now let's come back. So this whole AC is equal to 26. Now let's come to the figure here. So if this is the radius, so this can be also equal to the radius. Okay, this can, so if, and this forms a square. So if this length is radius r, so this area from here to here, from here to here, this is would be also r. And similarly, if this area is r, so this area would be also r. And we know the length, whole length. Let's take these two as 2 points, P and Q. So if we know that PB is R and whole length AB is 10, so what is going to be 10? AP would be 10 minus R. And similarly, whole length BC is 24 and BQ is R. So so QC would be 24 minus R. Now we have read a property that if there is an external point away from outside a circle, then both length of both the tangents are equal. So if this is a tangent and PQR, let's say this is R, capital R. This point of intersection is capital R. So if point A is outside the circle and these are two tangents, and we have read in the property that both the tangents would be equal, so this is also going to be 10r. Similarly, QR is 24, C is a point externally, so these two tangents would be equal. So if this one is 24 minus r, so this is also going to be 24 minus r. RC is also going to be 24 minus r. So now we know, as we have already calculated AC, AC is equal to AR plus RC. So we have already found what is the value of AC, that is 26 using Pythagoras theorem. AR is 10 minus R plus RC. RC is 24 minus R. So that is 34 minus 2R is equal to 26. So if 2R is here, and if we take 34 and minus 26, it's going to be 8. Hence R is 4. So in the question, what is the radius? So radius is 4. Now we have to find circumference. Circumference is 2 pi r. So 2 into pi into 4, which is equal to 8 pi. So the circumference would be 8 pi. So both of them, this is your radius and this is your circumference. Now next question. In the figure above, three identical circles with radius 5 are tangent to one another. Okay, if let's say these are 3 points, okay, are tangent to one another. If line L and M are parallel and tangents to the circle, okay, L and M are parallel, these two lines are parallel and they are also tangents to the circle. Okay, what is the value of H? So we have to find what is the value of H. So if these three are sent, so from here to here and from here to here, we can join them like this to form a triangle. So if this is 5, this is also 5, this from here to here, this is also 5, from center to here, this is also 5. So uh, the length would be 5 plus 5, that would be 10. Okay, now what we have to do here is we have to find what is the length of this one. Let's say A, this point is A, B, C and P, and we can also extend like this, Q, this is P, and we can also extend R. So we know that here what we have to do here is question number 5. First we need to find uh, this one by using Pythagoras theorem. If we draw a line AP like this, first we draw AP like this. So AP like this. So we know that this one is 5 and this one is 5. So what is going to be, so by using Pythagoras theorem, AC square, if we take this triangle APC, so AC square is equal to AP square plus PC square. So AP would be AC square minus PC square. So we know what is AC, both are 5 plus 5, that is 10 square, and PC, so this is the radius, so 5 square, so that would be 100 minus 25, which would be root 75. If we take root outside, 20, it can be also done 25 into 3, and we can take 25 square, so 5 root 3. So AP is 5 root 3. So we know that AP is, so we have to find H. H can also be equal to Q and R. So this is the center of, so this can be also equal to the radius R, and this is AP, and PR is also equal to the radius, as we know. So what we are going to R plus AP plus R. So 5 plus AP, 5 radiuses, and this length is also going to be equal to the radius, so 5. So it is going to be how much? 10 plus 5 root 3. So this is going to be your answer. This one is a tricky one. Now moving to the next question. Now in this question, in the sector above, segment AO is a radius, so this is your radius R. Similarly OC would be also, if the length of arc ABC, so this major arc ABC length is 12, so what is the area of the sector? So as we know, this is 90-degree here, so central angle of a circle is 360, so 360 minus 90 is, so this angle would be 360 minus 90, that is 270-degree. Now let's as length of arc is given, so length of arc is equal to theta by 360, so 270 by 360 into 2 pi r. So length of arc is 12, and this is 3 by 4 into 2 pi r, 2 times, hence after solving this 3 by 4, so 24 by 3 pi, so 8 times, so r is 8 by pi, so the radius is 8 by pi. Now we have to find the area of the sector ABC. So as we know, theta is 270 by 360 into pi r square. So r square, so radius is 8 square by pi square. So 8 by pi square can be written as 8 square into pi square. So this pi goes away. This is going to be 3. This is going to be 4. So 3 into 8 into 8 by 4 pi. So this is 48. So the answer would be 48 by pi. So this is your area. Now moving to the next question. In the figure above shows a sector O with radius r. Okay, sector with radius r. If the area of the sector, so if area of this sector, major sector is 3 pi. Okay, so is 3 pi. What is the perimeter? So we have to find this perimeter plus 2r. So first in question, area of sector, as we know this is 90 degree, so this is going to be 270 degree. So area of sector is theta by 360, so 270 by 360 into pi r square, and area is 3 pi, so 3 by and this one is 4, so 3 by 4 pi r square. So 3 here, 3 goes here, pi goes here, so r square is equal to 4, so r is equal to under root 4, that is 2. Now what we have to do is, first we have to find the length of this arc plus 2r. So first, length of the arc is theta by 360, so 270 by 360 into 2 pi r, 3 times, 4 times, 2 times, and instead of r is also 2, so 2 times. So length of arc is 3 pi. Sorry, length of arc is 3 pi. Let's calculate what is 3 pi on calculator. 3 into 3.14, that is 9 point, almost around 9.4. So we know the length of this arc. So so total perimeter is going to be length of arc, this length, this whole curved area, plus this r plus this r, length of arc plus r plus r. So 9.4 plus the value of r radius is 2 plus 2. So 9.4 plus 4 is equal to 13.4. So this is your answer. Now moving to the next question. In this question, in the figure above, point O is the center. Okay, point O is the center of the circle. If length of TP, so this is 10 by under root 3. What is the length of minor arc TM? So we have to find length of the minor arc TM. If this is 90 degree, this is 30 degree, so this is also going to be 60 degree. Let's see how we are going to approach this question. Yes, okay, as we have to find the value of OT first. From that only we have to find what is OT. So in trigonometry and right triangle chapter, we have read tan theta formula. So tan theta is equal to OT by height by base. Uh, Many also call this as opposite, and I call, in my country we call it as base, and in other country it is also called as adjacent. So tan theta, so the tan theta is equal to height by base. So the angle here is 30 degrees. So tan 30 degree, height is OT, and base PT is 10 root 3. So tan 30 is 1 by root 3 is equal to OT by 10 by root 3. So root 3 will be cancelled. So OT is equal to 10. So OT is equal to 10, which is equal, OT is, can be also called as radius. So this is your radius. Now we have to find, we know the radius now, we know the theta value. So now we can find the length of arc TM. So length of arc TM is equal to theta by 360. So 60 by 360 into 2 pi r. R is 10. This is going to go 6 times, 3 times. So 10 by 3 pi. This is going to be your answer. this is going to be, let me check, this is, yes, 10 by 3 is your answer. This is your answer. Pi is your answer. Now moving to the next question. In the figure above, central angle AOB has been has a measure of pi by 3 radian. So theta is given in radian. So if you have to convert it into degree, so 180, we multiply 180 degree by pi. So pi and 360. So this angle is 60 degree. If length of the minor arc is 10, what is the area of shaded region? So for that, first we have to find what is the radius r here, OB. So length of arc, minor arc AB is equal to theta by 360. So theta is 60 degree, 360 into 2 pi r. So 6 and 3. So length of arc is given in the question, that is 10. So length of minor arc is 10, so 10 pi by 3 r. So r is going to be 30 by pi. R is 30 by pi. Now what is the area of shaded region? So area of sector is equal to theta by 360, that is theta by 360, that 60 by 360 into pi r square. So r is 30 square, 30 by, and it can be written pi r square. So pi cancelled, this is going to be 6 times, so 900 divided by 6 pi. Let me find it, let me calculate it on the calculator. Area of sector by 6 pi is 9.55. This is going to be your answer. Now moving to the next question. In the figure above, two circles have a common center O. Okay, two rays from the center intercept circles at point PQRS. So PQRS. The measure of angle POQ. So the theta POQ, theta is equal to 2 pi by 5, that is given in radian. So if you have to convert it into degree, so 180 degree by pi, this, then how it is going to be 36 into 2, I think angle would be 72 degree. So this is 72 degree. POQ is 2. Now after that, the question says that the area of shaded region of sector OPQ. So area of sector OPQ. So from this we can find the radius of this smaller angle, and also it is said that OP and OR is in ratio. So let's find the radius of the smaller circle first. So in the question, area of shaded area is theta by, formula is uh, shaded area of a sector OPQ. So this is 20 pi, and the formula is theta by 360 degrees. So theta is 72 by 360 into pi r square. So 5 times, so pi r square by 5. So pi got cancelled, 20 into 5, so this would be 100 r square. So r is 10. So the smaller radius is 10. As as we move forward in the question, it says OP and O and PR is in ratio 2 is to 3. So if this is 2x, then this would be 3x. So we know that OP, that inner radius, is 2x, which is we that is equal to 10. So x is equal to 5. So what is going to be the length of PR? So PR is 3x. So this is going to be 15. So as we know, what in the question it is said that what is the length of minor arc RS. So first we need to find the radius of the largest circle, that would be 2x plus 3x, so 5x. So OR is equal to 5x, so 5 into 5, x is 5, so this is going to be 25. So the larger radius radius of largest circle is 25. So what is the length of minor sector RS? So length of minor sector arc RS is equal to theta by, so that is 72, theta by, if we take this thing as a whole, so 72 theta by 360 into 2 pi, and the radius is 5x, that is 25. So 25, so this will go 5 times, this will go 5. So the length of minor arc RS will be 10 pi. This is going to be your answer, 10 pi. Now let's move to the next question. So here in the figure, O is the center of the circle. Okay, O is the center of the circle. If area of circle is 100 pi, okay, and area of circle is 100 pi, and measure of angle is, so theta. So first we have to convert theta from radian to uh, degree. So theta into by pi. So this angle is going to be 30 degree. So this is 30 degree. What is the area of parallelogram OPQ? So we have to find area of this parallelogram. So one information given here is, if the area of circle is 100 pi, from this we can find what is the radius OP or OR, what is the value of that, we can find it from here. So let's say, sorry, area of the circle, from area of the circle we can find the value of the radius. So area of circle is pi r square. So in question it is given 100 pi is equal to pi r square. So r square is equal to 100, so r is equal to 10. So this OP radius and OR both are 10. Now what we are going to do more to find the area of parallelogram? Let's take a line from here to here, because uh, area of parallelogram we have uh, is height into base. So we already know this, so we need to find what is this, and then we can find. So let's say PA. Okay, so this is 90 degree, so this is going to be 60 degree. So so as we know, what is OP? So we have to find what is PA. So for that we are going to use sorry height. What is going to be the height PA? So for that we are going to use trigonometric function, that is theta sine theta is equal to height by hypotenuse. So PA by OP, and the angle between them is sine 60. So sorry, angle between them is, this is 90 degree, so we have to take this angle, so sine 30 degree is equal to PA by OP is 10. So the value of sine 30 is half, so half is equal to PA by 10. So the value of PA is equal to 10 by 2, that is 5. Now we know that area of parallelogram is base into height. So base, if this is a parallelogram, area of parallelogram OPQR is equal to base into height. So base is the equal to radius, that is 10, and the height, this one AP, which we have found, is 5. So your final answer is going to be 50. If you like the way I teach and want to buy a comprehensive course for SAT exam at a very affordable price, you can download our app from the App Store and start your self-paced preparation from pre-recorded videos provided in the course. My course also includes chapter-wise practice questions along with 20 test series at par with SAT exam. You can find all the links in the description below. Now let's move to the next question. Now in this question, let's see, in the figure above, O and P are centers of two semicircle of radius. So O and P are center of two semicircle of radius R. Okay, so radius, both them, the radius is R. Okay, length from here is R, radius. If length of the perimeter is 8 pi, so perimeter would be from here we'll go here, and from here we will go here. Okay, so from here to here, then from here to here. So this will be your perimeter. So the length of the perimeter is 8 pi by 16. What is the value of R? So if we take this one, okay, so if this is your this semicircle, and if you take the lower one, this will go like this. So perimeter of this would be equal to the circumference, that would be 2 pi r. Now we have gone from here to here. Okay, now we have to go from here to here. So if P is the center of this semicircle circle, then this is the radius, so this would also be the radius, and if this is radius, so this is also the radius, so plus 4r. So that is your total circumference. So the sorry, it's not circumference, the total perimeter. So perimeter is equal to, of these two, it will form a circle like this, so 2 pi r, and this line plus this line, so there are 4 r's, so 4 r, and the value of perimeter is 8. In the question it is given 8 pi plus 16. So we will take r common here, so 2 pi plus 4. So radius is going to be 8 pi plus 16 divided by 2 pi plus 4. Let me calculate that on a calculator. Mm, it is almost equal to 4. So your radius is 4. This is your answer. Now moving to the next question. Question number 13. In the figure above, two congruent circles are tangents to each other and are internally tangent to the larger circle. Okay, these two are similar circle, and there is a larger circle outside. They're internally tangent to the larger circle. So they are internally tangent to the larger circle. Line segment AB is diameter. Okay, diameter of the larger circle. This is the diameter. If area of smaller circle is 10, what is the area of shaded region? So if we take this one, this has a center, and this is the center. This is your radius from here to, if we take point this point as C, this is also from here to here, there will be the radius. So if the area of each small circle, so area of smaller circle is pi r square. So area is 10 as it is given in the question, and pi r square. So r is going to be under root 10 by pi. So this is going to be the radius. So now if we take the larger circle here, okay, and if the C is the center of the larger circle, so radius would be this one. CB would be the radius. So what is going to be the radius of the larger circle? 2r. So radius of larger circle is r plus r, that is 2r. So area would be area of bigger circle is equal to pi r square. So pi, and we know the radius r is 2r, so it would be r square. So 4 pi, 2 would be 4, and r square, so under root 10 by pi whole square. So it would be 4 pi into 10 into 10 by pi. So the area of larger circle would be 40. As we know that area of each smaller circle is 10. So if this circle is 10, and then this and these two smaller circles are congruent to each other, so this will be also 10. So shaded area would be area of largest circle, which is 40 minus these two circles, that is 10 plus 10, 20. So the area of shaded region is 20. So this is your answer. Now next question. In the figure above, the center of the circle is O. Okay, the area of the shaded region, so this region, the area would be 80 pi, shaded region 80 pi, and the measure of angle x is 2 pi by, so x would be, it is given in radians, so we have to convert it into degrees. So 2 pi by 5 into 180 degree by pi. So this is going to be 36 into, so it is going to be 72 degrees. So this angle is 72 degree. So if we know that the central angle is 360 degree, so if we subtract 72 from 360, then this angle would of shaded area would be 360 minus 72 would be 368 288 degree. So this angle is 288 degree. In question, area of shaded region is given. So area of shaded region, so area of shaded major sector would be theta by 360. So theta is 288 by 360 into pi r square, pi r square. So in the question it is given that the area of shaded region is 80 pi, and we can solve it as 4 times 72 4, and this is 5, so it is 4 by 5 pi r square. So pi got cancelled here, so 80 into 5 by 4 is equal to r square. So 20 times and 20 into 5, so r square is equal to 100, hence r is equal to 10. So hence the radius of the circle is 10. Moving to the next question. So in the figure above, each of the two triangles have same center O. Okay, this is your smaller circle, sorry, two circle. This is a smaller circle, and this one is your larger circle. Let us take smaller circle radius as r1 and the radius of larger circle as r2, and the area of shaded region is 40. So if we have to find this area, that would be this larger circle area subtracting the smaller circle area. So the shaded area is equal to, first we will take the larger circle, that is pi r2 whole square minus pi r1 whole square. So as in the question, one more thing is also mentioned here, that OP and OQ is in a ratio 3:5. So we have to also consider that that is 3:5. So let's take R1 as 3x and R2 as 5, as they are in ratio 3:5. So shaded area is given in the question, that is 40 pi. R2 is, if we can take pi common from both, so pi is taken common, so 5x square minus 5 minus 3x whole square. So it can be written as pi 25x square minus 9x square. So it can be further written as 50, so 16x square, 16x square. So if we take that on this side, 14 by 16 pi is equal to x square. Now what we can do here, anything else that we can do? So if we want, we can put it as uh, if you want, we can put it as 40 by 40 x square 40 by 10 pi 6, so this one is 16, We can also do one more thing here, 4 times, and this will go 10 times, and 2 times, 5 times. So it can also be written as 5 by 2 pi under root 5 by, if we, and we will take pi on that side, sorry, pi will go here. So 5 by 2 pi, this is this is going to be the value of x. If the area of, now let's calculate it. What is going to be x? Let me put it on the calculator. It would be 0.89. So x is 0.89, so we have to find the area of larger circle. So if first we have to find the radius of the larger circle, that is r2, which is 5x. So 5 into 0.89 would be, let me calculate, 4.47. so this is going to be r2, radius of the larger circle. So now we have to find the area. So area of larger circle would be, pi r square, 4.47 whole square. So if we calculate 4.47 whole square into pi, it is going to be 62.74. So this is going to be your answer here. Now moving to the next question. Here in the figure above, O and P are the center. So as we can see, this is one circle here, this, and this one is another circle here. Okay, and center of this circle is O and center of this circle is P. If length of the radii of the circle are each 10 meter, so if we take this as the center, so this would be radius, so this is going to be 10. Similarly, this is also going to be 10. From here to here it is touching at the from center to the circle, but this is also going to be 10, and this is also a radius, so this is also going to be 10. So we have to find the area of, so this is a parallelogram, which is, but to find area of parallelogram you need to know the height, and height is not given here. So what we are going to do here is we are going to divide it. Okay, now as you can see, if you're taking this as a whole circle and this is a center, so OP length would be also equal to the radius. So it is going from in this circle, it is going from center to the circle, so this is also going to be the radius, so it is 10. So let's say OPQR. So in triangle OQP, तो इसका area, it is an equilateral triangle, all the sides are equal. So area of an equilateral triangle is formula is under root 3 by 4 into a square. So 3 by 4 into 100, that would be 25 times. So the shaded area would be, if this is, these two triangles are similar, so if area of this is 25 root 3, so this would be also same. So shaded a region would be twice into 25 root 3, so your answer would be 50 root 3. So this is going to be your answer. Now this is your last question. This is a real deal question. This was asked a few years back. So let's take this question. In the figure above, circle O and P are tangent to line L. So these two circles and this line the line L is tangent to both the circle. If radii of the circle O and P are 4 and 9, so for smaller circle the radii this one would be 4, and for bigger circle it is the radii would be 9, so PQ is 9. What is the area of quadrilateral? So quadrilateral, so we have to find the whole area. So now what we are going to do, so OR is PQR. If we take this point as S, so this can be also 4 because it is also the radius, so this is 4, this will be 4, and this is similarly like PQ is the radius, so this can be PS can be also be the radius of the larger circle, so it will be 9. So the total length would be how much? 9 plus 4, so OP would be 9 plus 4, that is equal to 13. Now quadrilateral, we cannot put the quadrilateral formula, so now what we are going to do is we will draw a line like this parallel to RQ. Let's draw a line parallel to RQ. Okay, so we uh, put it as T. Okay, so if this area is OR is T, so OR is 4. Similarly, this is if we make a line parallel to L like this from O to T, so this, so if OR it forms a rectangle, so these two sides will be equal, so TQ OR is equal to 4, which is equal to TQ, and we know that PQ was 9, radius of larger circle, so if this QT is 4, then PT would be 5, so this would be 5, PT is going will be 5 and TQ is 4. Now we can see, we know in this triangle we know we know the two sides, so we can find OT this line by using Pythagoras theorem. So using Pythagoras theorem, OP square is equal to PT square plus PT square plus OT square. OT square. So OT would be under root OP square. OP square is 13. So 169, and PT, that is 5 square, that is 25. So what is going to be the value of this is 4 4 4, so under root 144, which is equal to 12. So we know that OT is 12. OT is 12. Similarly, this is a triangle, so both the sides RQ will be also 12. So now we know that this quadrilateral can be divided into two parts, one as a triangle OPT, and as a rectangle ORQT, as a rectangle. Now we have to find areas of both the areas, and then we can, so first let's find area of right triangle OPT. So the formula would be half into base into height. That would be, base is this one, 12 into height, that is 5. So area of triangle would be 30, and area of rectangle ORQT is uh, length into breadth, that would be 4 into 9, sorry, 12 into 4, 12 into 4, so 12 fours times 48. So if we add both the areas, area of 8 and 78. So area of quadrilateral OPQR is 78. This is your answer.